So good morning everyone. Let's try to discuss second year physics problems today. Hope you are all aware of these sessions going on. We have been teaching since last 4 days. First we tried to cover first year physics formulas. The other day we covered second year formulas. And yesterday we covered first year problems, and today we are going to cover second year important concepts that are being repeated every year. So come on, good morning everyone, people online. Open your books. I'll be giving questions in between. Keep solving, check whether you are getting them right or wrong. Don't just watch it like a movie. So hope you are ready with your books and pen. So good morning. Good morning Adya, good morning Sarika, good morning Yash, good morning Gayatri. Come on, open your books. Ready, shall we start? So as said earlier, we have a revision session going on. So if you have missed any session, go back to the revision playlist and check the formulas and concepts being covered since last 2 to 3 days. So people do like the session, share the session so that many get benefited. Now today we are going to discuss second year physics important concepts that are being repeated. So good morning Arjun, good morning Dikshit, good morning Shobha. Come on, open your books. So we are trying to start with the easy question so that you don't lose your confidence. Then we'll be getting into tricky questions. So this is just a kind of warm-up question. So find the power dissipated in increasing order. Arrange them in increasing order. That means ascending order. Try to arrange A, B, C, D on the basis of power dissipated in increasing order. So find R equivalent for each. Okay. And try to solve. So, two coherent point sources of S1 and S2 in phase emit light of wavelength lambda. The separation between them is 2 lambda. The first bright fringe is formed at P due to the interference on the screen placed at a distance d from S1. Okay. Then OP is dash. So come on. So people online, start solving the question. Hope the question is clear. So find OP. So good morning Kasturi, good morning everyone. So find OP. See, it is a question of Young's double slit experiment where two sources are given S1 and S2 with a distance of 2 lambda. The wavelength of the light emitted is lambda and the distance from screen to S1 is d. Find OP, where at P the first bright fringe is formed. So very good morning Adya. So check. So people watching online, do share, like the session. We are doing it for free. So your likes really motivate us and helps us to do more such sessions. We brought really important questions that are being repeated every year. So your encouragement really boosts us and motivates us to do more such videos. At Sagarika, cheat codes will be discussed once we are done with the real physics, right? So do like this session and share the session and subscribe Roots Academy. Okay, we got answer for first question. How about second question? People are Nandan Reddy. Okay, good. So how about the second question? Try to solve. See, S1 and S2 are in interference and first bright fringe is formed at P. Try to find the distance x in terms of D. Okay, yes. See, latecomers, just go back a couple of minutes as you are watching online and you can go through the question. How about this first answer? 3241. So let's try to discuss. So what is R equivalent here? 3R, right? Because they are in series. So how about this? 2R plus R. So these two are in parallel. So here you need to find R equivalent. What it is? 2R by 3. 2R by 3. Okay. So here 3 are in parallel. So how much do you get? 1 by R1? R by 3, right? Here 2 are in parallel and another is in series, 3R by 2. So the question is, what is the power dissipated? It is nothing but I square RT. So the power dissipated is proportional to R. So the one which has the least R will be dissipating least power. So it will be C first, next B, next D, next A. So this will be the order. Hope you many of them got correct. So come on. So good morning everyone. So how about the second question? How do you do that? So people watching online, come on, try to do the question. See, how do you start this? See, first, see for formation of, for bright band formation, the path difference should be n lambda, right? The path difference should be n lambda. So then how will you proceed? So now try to find the theta. See here n is 1. We are trying to find the first band. So at P first bright, right? So cos theta is equal to path difference by S1 S2. Which is nothing but n lambda by 2 lambda. Here it is 2 lambda. We have, so theta will be 60 degrees. Cos half. So from triangle S1 OP tan theta is equal to x by d, right? So using this and find x. See, this is a basic fundamental concept. 3 root d, right? Root 3d. So come on, people watching online. See, only this is all basic mathematics. You need to know this. For a bright band, it will be n lambda, and cos theta is equal to path difference by S1 S2. So once you are aware of this formula, there is nothing complex in it. So hope people online are doing good. So come on, post your answers. See, these are important questions that are being repeated every year. So try to focus on them. Initially, a magnetic needle parallel to field magnetic field and is turned through through 60 degrees. The work done is W. The torque required to maintain the magnetic needle in that position will be. Write in terms of W. So you will try to get answer in terms of W. So a magnetic needle is parallel to the field. It is turned through 60 degrees and the work done is W. Torque required to maintain the magnetic needle in that position in terms of W. So people watching online, open your books, start solving problems. Okay, let's check. The mutual inductance is 92 into 10 power minus 6. Then the value of induced EMF in secondary coil. See, two coils, primary and secondary, are close to each other, and the current changes at a rate of 25 amps per millisecond is present in the primary coil. If the mutual inductance is 92 into 10 power minus 6 henries, then the value of induced EMF in secondary coil. So come on, 2.3 okay, it is 2.3. How about first one? Sorry, wrong. Check. Come on, Santosh. Okay, you got right. Check, check. Okay, Santosh, you need to check. Even that is not right. Come on, Josna. Come on. Okay, Soumya, you got it right. Come on, people watching online, do share the session, like the session, so that many get benefited. Root 3W. So come on, people watching online, first one answer root 3W, second one 2.3 volts. So yes, start solving and share your answers, whatever you got. So how do we approach? Okay. Okay. Then where you went wrong? Okay. So as for our basic fundamental equations, torque is equal to mb sin theta. Okay. So theta 60. Torque is equal to mb root 3 by 2. So work done is equal to mb cos theta 1 minus cos theta 2. So it will be 0 minus 60. So cos 60 half. So it will be mb by 2. So here mb, from this equation, from equation 1 and 2, we can make out torque is equal to root 3W. Okay, 1 minus, sorry. So okay, so something you will get here. So use the formula and you will get torque required is equal to root 3W. Okay. So how about this? I guess. So I guess that is direct formula, right? Right. So from the direct formula, EMF is equal to m di by dt. So you need to take care of this millisecond, and once you take care of this millisecond, you will get 2.3 volts, right? So now let's try to do some more questions. I guess this is a theory question that is being repeated. Layers of ionosphere. For sky wave propagation, D layer, E layer, F1 layer, F2 layer. So A 250 to 400 kilometers, B 170 to 190, 95 to 120, 65 to 75. So a proton, when accelerated through a potential difference of V, has a de Broglie wavelength of lambda. If an alpha particle is to have the same de Broglie wavelength, it must be accelerated through a potential difference of dash. First one you are saying, let me okay. One. Or did you say DC? Okay. DCBA. So it is D C B A. So nothing but layer D 65 to 70, E layer C 95 to 120, F1 B 170 to 190, F2. I guess this is completely theory question, right? There is no logic in it, completely theory. So how about that second question? Okay, DCBA correct. Santosh Kumar. Soumya correct. So come on, people watching online, do like the session, share the session, so that many get benefited. See, important concepts are being covered, which are being asked repeatedly in many competitive exams. So try to check whether you are getting them right or wrong. Okay, Soumya, you got it right. Okay, Soumya, doing good. Come on, people are working online. Come on, share your answers. Do like the session, share the session. Come on. So, good morning, Shankar. Come on. So, people working online. Okay, Sujit, root 3W, it was right. Come on. So, how about the other answers? We are doing other answers as well. Try to answer this proton problem. This is basic fundamental question. Yes, Kasturi Rathod, you got it right. Come on. Yes, Adya, come on. Shashi, check. Naveen, check. Check where you went wrong. Okay, Gautam, come on. Naveen, come on. So, how much do you get? Sorry, no. So, lambda is equal to, what is the formula? H by P, right? Which is equal to H by 2m QV. Lambda 1 by lambda 2 is equal to under root of m2 q2 v2 by q1 v1. So, if you try to proceed, given that lambda 1 is equal to lambda 2 is equal to lambda. So, find v2. See, hints are given. Come on, people working online. Okay, some are really doing good. How do you find v2? Right, you get v by 8. So, we finally get v by 8. Come on. So, come on, people watching online, share your answers. Come on, people watching online, share your answers. So people watching online, come on, share your answers. So people watching on app, come on, share your answers. Come on, people watching online. Okay. Yes, Akanksha, you are saying that. Okay, check Akanksha. Check. So you attempted really good check. I guess you went somewhere wrong in the last part. So Soumya, you are wrong. Come on. So people online, share your answers. See, three charges plus q and q are kept along a right angle isosceles triangle whose side is A. Given that net electrostatic potential energy is 0, find q. So how do you find it? Come on, people working online. Sai Kumar, -1, 1, 2, -2. What is the answer? Which choose? See, Mr. Sai Kumar, it depends on the question. You cannot blindly say without question. Okay. See, going for cheat codes should be the last option. You can hardly answer few questions using so-called cheat codes. So don't completely rely on them. So come on, try to solve the question. So how do you solve this electrostatic potential energy? Net electrostatic potential energy. See, it is nothing but K Q1 Q2 by R Q2 Q3 by R2 plus K Q3 Q1 by R3, right? So solve according to this. So net potential energy is equal to k q1 q1 q2 by r plus k q1 q2 by r2 plus q q. Substitute the given notations in it and find capital Q. See, Akanksha, you get in terms of Q. Okay, I guess you are saying the other question. Half-life, huh? Okay, Akanksha, Soumya, you are correct for question 2. How about this question 1? Okay, okay, Soumya, you are right. Come on, people working online, you need to share. How much? So it is basic direct question, okay? Come on, people watching online. Okay, I guess if you try to simplify that, you will get something like this. Still, if you try to simplify. If you try to still simplify, you get something like this. Minus 2q by 2 plus root 2, right? If you try to, this will be the final answer. So if you try to simplify, you will get something like this. Come on, people. Okay, Mr. Raj, you are right. So how about this? See, what is the question is that the fraction of particles that will decay at the end of 10 seconds. So how do you solve? No idea. See, we know that n by n naught is equal to so half of T by, do you know this? Where n is the total amount of particles at given time, n naught is the initial, half into T by T, capital T is nothing but half-life. So you will get something as 2 power minus 1 by 6, right? So what is being asked? Fraction left. So nothing but fraction decayed, sorry. So 1 minus 2 power 1 by 6. See, this is left at the end. So the other part will be that has got decayed. So come on, people working online. I need more answers from you. Okay, Raj, you are right. Come on, still. So questions that are being repeated every year or similar concepts are being discussed. So try to focus. So the question is, ammeter shows 0 reading. In the circuit shown below, the ammeter reading is 0, then find the value of R. So come on, people working online, post your answers, share your answers and involve in the discussion. Come on, try to answer the question. Okay, Raj, you got it right. Soumya, wrong. Check. Soumya, check. So, hi, Lakshmi Priya. Open your book. Start solving problems. Good morning. Come on, people watching online. Share your answers. Share the session so that your friends get benefited. So come on, people watching online, do like the session, share the session. See, we are putting lot of efforts and providing it for free. Your likes really motivate us to do such more sessions. So like, share and subscribe. Come on, do first and second question and post your answers. Come on, Soumya, you 125, you got wrong. Check. Okay, reviewer. Okay, Soumya, correct. How about the second? So come on, people online. So how do you solve? Try to apply Kirchhoff law. What do you get? Kirchhoff's second law, what does it say? Voltage in a loop is 0. Chalo, there are two loops. Check the direction of current. Apply them. The only condition is ammeter reading is 0. Okay, Anjaneyulu, correct. Come on, still people working online. See, what is the direction of current in left loop? What will be the direction of current? You get 100 ohms. So the direction of current is this way, right? So how about in right loop? This way. So the direction of current will be opposite to the direction of flow of electrons. So electrons flow from negative, so as the long line indicates positive terminal, short line indicates negative terminal. So the current moves from positive to negative. So if you try to apply Kirchhoff's law for a left side loop, it will be 500 minus 500 I1, right, minus R I1 plus I2. Okay, I take this as I1, I take this as I2. Okay, plus 12 is equal to 0, right? First left loop. If I try to take the right loop, the current will be in this direction, right? So minus I2 R1, sorry, minus I1 plus minus I2 R1 I1, sorry, I1 plus I2 into R plus 2 is equal to 0. So if you solve this, you get R as 100 ohms. So how about this? So magnetic field intensity ampere per meter, right? So H. Magnetic flux Weber, okay, G. Magnetic pole strength ammeter E, okay. What is magnetic induction Weber per meter square, right? F. Yes, Lakshmi Priya 100, come on. So people working online, do share this session. See, the important concepts are being covered, which are being repeated in every year, so you can easily expect a question from any competitive exam. So the I Okay, let's check. See, a fully charged capacitor C got discharged through a resistance wire which is embedded in a block of specific heat S, mass M, under thermally isolated conditions. Okay. See, a fully charged capacitor has a capacitance C. Okay, it got discharged through a small resistance wire which is embedded in a block of specific heat S, mass M, under thermally isolated conditions. The temperature of the block is raised by delta T due to this discharge, and the potential difference V is across capacitor initially See, the question is, a fully charged capacitor has capacitance C. It is discharged through a small coil of resistance wire which is embedded in a block of specific heat S and mass M under thermally isolated conditions. The temperature of the block is raised by delta T. The potential difference across the capacitor is dash, which is initially V. So the value of V in terms of the given variables S, M, C, Ms delta T C. Hope you got the question. The question is a bit lengthy. So come on, people working online. Okay, Soumya, you are done. Okay, correct. See, the question is bit lengthy, so try to understand. See, basic, but the answer is looks so simple. The question is very lengthy. It's around 3 lines. So Santosh Kumar, check. Yes, first question answer 4 amps. Okay, I guess it's a very easy question. Kirchhoff First Law. So try to answer the second question. The question is very lengthy, but the answer looks so simple. So how do you solve it? Okay, Raj, correct. See, the capacitor which is initially fully charged gets completely discharged. Completely discharged. So what is the initial energy stored? Half CV square, right? half CV square into is equal to. So how do you check? So it is completely transferred to the block. So MS delta T. So he is asking V. So direct one step equation. So this is Kirchhoff First Law. So the sum of currents at a junction is equal to 0. So people working online, okay, you are doing good. Very small resistance, like he said. See, it is resistance is within the block. See, the resistance is embedded in a block. So the resistance, manaku capacitor is getting discharged because of resistance. See, if there is no resistance, it won't get discharged, right? So the heat generated within the resistance is transferred to the block. So that's how it travels out. So come on. See, a ray of light refracts from medium 1 to medium 2 into a thick layer of medium 2, crosses a layer and is incident at the critical angle on the interface between the medium 2 and 3. Okay. The angle of incidence is theta. Find the value of theta. See here, see it crosses the layer and is incident at the critical angle on the interface between the medium 2 and 3. Here it gets interfaced. Here the angle of incident is critical angle. So hope you got the question. So let me read. A ray of light refracts from medium 1 into a thick layer of medium 2, crosses the layer and is incident at the critical angle on the interface between medium 2 and 3 as shown in the figure. So if the angle of incidence of ray is theta, find the value of theta. Yes, we can expect similar questions. Come on, people watching online, share your answers. So check. Okay, let me complete this and we'll do. So the second question is, the wavelength of two sound nodes in air are 40 by 195 meters and 40 by 193 meters. Each node produces 9 beats per second separately with the third node, okay, of fixed frequency. The velocity of sound in air is dash. Okay, Akanksha, you are right. Soumya, right. Raj, check. Come on, try to do the second question. The second question says that two wavelength of two sound nodes are given. Each node produces 9 beats per second with the third node of fixed frequency. So find the velocity of sound. Okay, Khan, correct. Come on, how about the second question? Yes, Soumya, correct. Raj, correct. So how about second question? Hope you got the question. Huh. So find the, okay, people are doing good, come on. How about others? So do share the session so that your friends get benefited. Okay, Ramakrishna Yadav, correct. Gautam, correct. Bhaskar Raju, correct. Adya, correct. Come on. See, we know we have direct equation. So first let us try to solve the second one. Okay. See, we know that the number of beats produced per second is equal to the difference between the frequencies of sound producing sources. So if V is the speed of sound, then from the above statement we can write as 195 by 40. I am trying to write the hint. You solve using this 9, okay. First equation. The second equation says that n minus 193 V by 40 is equal to 9, where n is the frequency of the third node. Okay. Find V. How do you get, how much do you get V? Okay, definitely we'll try to do from modern physics and we'll try to do questions from modern physics and communications as well, electromagnetism as well, definitely. So I guess you got this as 13 by 16, right? 13/16. Check. See, from figure we know that mu2 by mu1 is equal to sin A by R. 360. Yes, you get something as 360. Okay. So mu2 by mu3 is equal to 1 by sin C, because the angle of incidence between 2 and 3 is the critical angle. So from these two equations we can make out theta is equal to, what is this, C. So sin theta is equal to, you will get something as 13/16. So come on, people watching online, do share this session, like this session. So we are trying to cover the important questions that are being repeated every year. Semiconductors, no? Okay. Will do. See, the question is, a short bar magnet in a vibrating magnetometer makes 16 oscillations in 4 seconds. Another short magnet with same length and width having moment of inertia 1.5 times that of the first is placed over the first magnet and oscillated. Neglect the induced magnetization and find the time period of the combination. Okay, the second question says that a parallel plate capacitor has a capacity 80 into 10 power minus 6 farad when air is present between the plates. The volume between the plates is then completely filled with dielectric slab of dielectric constant 20. The capacitor is now connected to a battery of 30 volts by wires. The dielectric slab is then removed. Then the charge that passes through the wire now is dash. So come on, solve the question. So time period for the combination case 1 and charge. Which one? One not. I guess there is no option as such. Check. So come on, people watching online, share the session. Come on, people watching online. Okay, Raj, you are correct. So how about, so you are correct for the second question. How about first question? Okay, Sanjay, check. Raj, you are correct. People watching online, share the session. So how about Soumya, first question answer? So you need to read basic oscillations, man, Mr. Raj. So you can get easy questions as well. So you will miss a lot. You cannot leave a chapter completely as a whole. Okay, Soumya, still you are going wrong. Come on, check. So how do you solve this first one? See, if their magnetic moments are equal, T1 by T2, I'm trying to write the hint, you try to solve. T1 by T2 is equal to I1 by I2. When their magnetic moments are same. So from there you can get, I guess in question he gave somewhere. So see the ratios, initial case, final case. Initial only one magnet we are trying to take. In second case, combination. So if you try to solve that way, we will get time period 2 as C. We have 1 by 4 by T2 is equal to under root of So if you proceed that way, you can make out there is nothing big here. So how about this one not this capacitor question? See, how did you solve this capacitor question? See, what is the initial? First one, you get something as 2.5 by 2 root 10, something this way. You get something this way. So what is the charge stored when air is present? See, when you try to place a dielectric between a capacitor, will the amount of charge gets increased or decreased? Increases. So in case 1, when there is no dielectric constant, what is the charge stored? Q is equal to CV, right? Something you will get. So when the dielectric is placed, so into 20, so kCV. So when the dielectric is now removed, so how much? See, it's filled with dielectric constant, now connected to, see, you are thinking that voltmeter is removed. Why will voltmeter get removed, man? See, dielectric is removed, then see, initial Q, CV, Q1, Q2, kCV. When dielectric is removed, it will be still Q2, right? So the difference between these two charges will flow through the wire. Q1. So you will get something as, so this is Q1 is 2.4 into 10 power minus 3. So this is 48 into 10 power minus 3, something as 48. 24, here it is 2.4, check. Then final answer you will get as 45.6 into 10 power minus 3. See, people answered here 45.3. Come on, good. So people working online, hope you are getting. Come on, people watching online, do share your answers. See, where do we place voltmeter? Here or here? Is voltmeter connected in series or parallel? Voltmeter. What do we use voltmeter for? So how do you connect voltmeter? So ammeter you connect parallel or series. Let's check here. So see people working online. So how do we connect voltmeter? Do we connect in series or parallel? Yes, Soumya, she's saying parallel, parallel. Voltmeter we connect in parallel, ammeter in series. So try to answer this question. Okay, Soumya, correct. Still people working online. See, voltmeter is used to measure the potential difference, ammeter is used to measure the current. No, check. See, the second question is a series LCR circuit is connected to a source of alternating EMF 50 volts and the potential difference across the inductor capacitor are 90 and 60. Inductor 90, capacitor 60, right? And the potential difference across the resistor. Come on, people watching online, share your answers. Sorry, Raj, wrong. So people watching online, come on, share this session so that many get benefited. So how do you answer the second question and first? Okay, Raj, correct. How about first one? So people share the session, like the session, do subscribe to Unacademy. This really encourages and helps us to do more such videos such that many get benefited. So your likes really encourages. So how to solve the first one? See, effective resistance is equal to right? From Ohm's law we apply V by I. How much you get? 2500 into R. See, you will get 51. 51, right? So how to do this question? Second question. Okay, Adya, right? Soumya, right? See here it is given as 50 volts, right? Hope you are okay with that equation. So from that equation you can directly get. Come on, people watching online, share this session. 40, okay. See, a water film is formed on a glass block. A light ray is incident on water film from air at an angle of 60 degrees with normal. The angle of incidence on the glass slab is dash. From air, the angle of incidence on water is 60 and the glass is below the water, and find the angle of incidence for glass. See, the second question is, two identical fluids produce fundamental notes at frequency of 300 Hz at 27 degrees. The temperature of air in one of the fluids is increased to 31 degrees. The number of beats heard per second will be. Come on, people watching online, do share the session. So, hi Ravinder, open your book, start solving. Which one? Second one. Okay, how about first one? Okay, Soumya, correct. How about second one? Okay, correct. Both are correct. Come on. See, how about other guys? People watching online, do share the session. See, how do you solve this first one? Mu of water is equal to sin I by sin R, right? So you get sin R as 3√3/8. For water glass media, angle of incidence is equal to angle of refraction in water. So I is equal to sin inverse 3√3/8. See, for water glass medium, it is the case. So if you try to look at see, the condition is for water glass, angle of incidence is equal to angle of refraction. Which one? Huh. See, we are not going for Snell's law actually. See, what is being asked here? Ratio of refractive index. Sorry, formula for refractive index. What is that? See, okay. Huh. See, first from air, water, next glass. This is the pattern. From air it is entering into water, then next it is trying to entering into glass. So then we will get right. So we try to ignore the air because mu is almost 1. So how about the fundamental notes question? So come on, people watching online, do share the session. So okay. See here, for a closed tube, N is equal to V by 4L, right? N1 by N2 is equal to V1 by V2 is equal to under root T1 by T2 is equal to under root 300 by 304. This is nothing but we are into Kelvin, 300 Kelvin, 304 Kelvin. Okay. If we try to proceed this way, we get N1 and N2, which is equal to 2, N1 minus N2, N2 minus N1, sorry. You get 2 bits. Come on, people watching online, do share the session. Okay, Soumya, correct. So let's try to do more questions. See, these questions are being repeated. See, the velocity of jet plane is 950 km per hour. Find the EMF induced between the ends of its wings. The vertical component of the intensity of terrestrial magnetic field is 0.5. And using the length (12.5 meters). See, the velocity of jet airplane is 950 km per hour. Find the EMF induced between the ends of its wings if the vertical component of intensity of magnetic field is 0.5 and using a length of 12.5 meters. Come on, people watching online. Try to do this question. It's a bit tricky question.
See, the second question is, a Zener diode voltage regulator operated in the range of 120 to 180 volts produces a constant supply of 110 volts and 250 milliamps to the load. If the maximum current is to be equally shared between the load and Zener, then the values of series resistance and load resistance are. Then the values of series resistance and load resistance are. Come on, people watching online. See, the first question is, the velocity of jet airplane is 950 kilometers per hour. Find the EMF induced between the ends of its wings. If the vertical component of intensity of magnetic field is 0.5 and using the length as 12.5 meters, length of wings. Yes, people watching online, do comment your answer. Okay, Soumya, correct. Second one correct. How about first question? Zener diode. Okay, you are right. How about first question? See, the units of magnetic field given here are Oersted. OERSTED. Hope you got it. Try to find the unit conversion and find the answer. Okay, second question correct. So people watching online, do share the session so that many get benefited. So how do you solve first one? 0. Okay, correct. How about this second one? See, the question looks complicated, but the answer is very simple. Come on, first answer. Okay. See, the velocity is given as 950 kilometers per hour, right? So convert it into meters per second. So 950 into 5 by 18, you get as some meters per second, in meters per second. Okay. So the area traced, area is equal to L into V. So length 12.5 given into velocity, right? Induced EMF E is equal to d by dt of magnetic field into area, right? That's what is being asked. So the conversion is 0.5 into 10 power minus 4 gives us the SI unit of magnetic field. So you will get as 164 millivolts. So hope you got it. So people watching online, do share the session. Yes, maths class will be followed by physics class. So please be connected. So come on, how about this question? This is direct formula. Hope you got it. So come on, people watching online, do share the session. We are trying to cover important concepts. Most typical type of questions are being covered. So don't miss this session. Share to your friends as well. Come on, people watching online, do comment your answers. Only very few are trying to answer. See, this is last chance for you to cover the entire concept in one shot. So don't waste it. So you can expect gunshot problems from these concepts. See, the question is the dispersive powers of the materials of two lenses forming an achromatic combination are in a ratio of 4:3. Effective focal length of the two lenses is plus 60 centimeter. Then the focal length of the lenses should be dash. Come on, people watching online, do share the session.
Come on, people watching online, share the session. Try to comment your answers. Come on. So do like this session, share the session, so that many gets benefited. We are trying to cover as many concepts as possible. Come on. Okay, Soumya, correct. Come on. How about first question? Okay, how about second question? Okay, first question correct. So people watching online, come on, share the session so that your friends get benefited. See, this is the last chance to cover entire subject in one shot. Okay. So Mr. Vivek, simplify that and answer. Give me the final answer, okay? So people watching online, come on, share the session. See, these questions are being repeated almost every year. Okay. So okay, Soumya, I guess you are right. What is the work done? Right question is what is the okay. So what is this first question? Dispersive powers, right? Where is this question? Second one, huh? Check. So people watching online, do share the session. Okay, let's try to do this. See here, it is given that W1
W1 by W2 is equal to minus F2 by F1 is equal to 4 by 3. So I am trying to write the hint, minus F2 by F1. So F2 is equal to minus 4F1 by F3, and it is said that the effective focal length F1 F2 by F1 plus F2 is equal to 60 centimeters, right? So substitute here and find F1 F2. So if you try to look at the other question, -15 minus 20, right? So something this way. So here it is said that V power gamma minus 1 into T is equal to constant, right? Given that V is proportional to T power 2 by 3, right? Okay. So gamma is equal to minus half from this. So we have work done is equal to N into, see there are different ways you might have done in different way. So check dt is equal to, we will get something as 166. We will get something as 166.28, right? Hope you got it. So people watching online, do share. Yes, Mr. Pandey, we have been provided. This is the 4th session for physics. We are in first session we took first year formulas, second session second year formulas, third session first year problems, and today we are trying to cover the remaining concepts in physics. So if you watch, you will get a lot of benefit, so no worries, go ahead. We have these videos are available in playlists. Okay, so basically these are being done for your last minute preparation, so last time revision. So we are taking enough care so that all important concepts get covered. See, maths class will be followed, next follows chemistry class. Come on, people watching online, do like, share the session so that many get benefited. 20 and 100. Okay, let's check. Okay, let's check. First, let me complete this. See, we are trying to cover basic fundamentals as well. So come on, people watching online, comment your answers. Yes, definitely, Mr. Pandey. These are basically to cover your basic stuff before the exam. So do watch the videos, try to solve the problems given so you can score maximum. So do share the session. So this is 20 and 100, right? Okay. So how do you get beta is equal to alpha by 1 minus alpha, right? So straight formula. So find beta 1 and beta 2. Beta 1 20, beta 2 100. Okay. How about the second question? Okay, it is LR circuit, right? So at time t equal to 0, potential difference. The basic fundamental conceptual question, you don't need formulas and all. Inductor and a resistor are connected to a AC circuit, I guess, some circuit. So initial potential difference is 25 volts. Right? 25, okay. So at time t equal to 0, how about capacitor? For a capacitor at time t equal to 0, see, okay, first let us try to talk about the resistance offered by inductor at time t equal to 0. Will it be 0 or infinite? Resistance offered by inductor at time t equal to 0. Come on, people watching online. Resistance. Here you are saying that potential difference 0 and 25. Reverse you are saying, okay. So at time t equal to 0, we are saying that inductor offers 0 resistance. So 0 potential drop. Is that what you are trying to say? Think. Inductor, capacitor, resistor. See, resistor is always constant, okay? No worries about resistor. So think about inductor and capacitor. Resistance is 0. So potential difference 0. Potential difference across the inductor. So think. So difference between inductor and capacitor at time t equal to 0. See, at time t equal to 0, inductor offers infinite resistance. So complete potential drop will be across inductor. So as there is complete potential drop across inductor, potential drop across resistor will be 0 because total will be 25. So at time t equal to 0, inductor acts like a open circuit. Okay. So be aware of this. So people watching online, do share this session. See, why do you think inductor offers infinite resistance at time t equal to 0? What happens at time t equal to infinite to the resistance of inductor? See, at time t equal to 0, what exactly happens is that initially the current is 0. We are just closing the switch. So current increases. The di by dt keeps increasing. So there will be a resistance offered by inductor. So the complete potential drop across the inductor. So at time t equal to infinity, I becomes constant and di by dt will be 0. So the inductor won't offer any resistance. So in case of capacitor, it is completely opposite. Like at time t equal to 0, the both plates are not charged. So it offers 0 resistance. At time t equal to infinite, like both plates get charged and they offer infinite resistance. So inductor and capacitor act absolutely opposite to each other at time t equal to 0 and infinite. Come on, people watching online. So people watching online, try to solve the question. These are being repeated. See, a wide variety of questions are being covered, like easy, tough, fundamentals. So a lot of efforts is being taken. Lot of efforts are being taken. Come on. So do like, share the session. It really encourages us and motivates us to do many such sessions. So come on, people watching online, do the questions, like the session, share the session, comment your answers. Okay, Soumya, correct. How about second one? See, some people are actively participating, some are involved in unnecessary things. So we hardly have time left. So make most use of it. We are putting lot of effort so that all concepts get covered. It really helps you as a revision. Come on. So people watching online, share it to your friends. So do like the session, share the session. What is first answer? No idea. Come on. Okay, correct, Soumya. Okay, she is doing really good. See, how do you solve this? How do you solve this? Sensitivity of galvanometer. See, I'm trying to write. So how much do you get? So try to give me the answer. Come on, people watching online. So what is this S? 4. That one? Hope you got it. Chalo. So a ball Come on. See, a ball is dropped into a well. The water level in the well is at a depth of h below the top. The speed of sound is v. Then after what time the splash of sound is heard? Come on, people watching online, do share the session, like. Check, check, check. See, it's a bit complicated. You need to think, okay? See, I'm trying to cover easy questions, hard questions, fundamental questions. I'm searching a lot for your questions actually. So come on, make use of it. Okay, here Soumya is doing so good. I guess it is correct. Okay, try to derive that formula. Okay, remembering is not that easy. Actually, you can. It's a direct formula. Okay, try to derive it. It will help you for other exams as well. Come on, people watching online. With gravity G. So come on, people watching online, try to derive that. Okay, this is a standard equation. If you know, even if you know, try to derive it. H by, okay, something you will get that only. Check once. I have to see. Come on, people watching online. A hollow sphere of copper is having a uniform charge density of 0.5 microcoulomb per meter square. Its radius is 0.1 meter. The potential at the center of the sphere is dash. Come on. So answer for second question. People watching online, do share the session. See here it will be something like see the total time is equal to time taken for the ball to reach water plus time for sound to come up. See, hope you got this. See, basic equations of motion gives you the answer of where v is velocity of sound. Okay, people watching online, try to solve the second question. So share the session so that many get benefited. So do like, share. It really motivates us, encourages us so that we can provide more such sessions. So Mr. Gautam, try to solve the question. Come on. How much do you get? Yes. See, check Soumya. It's not 180. Check. It's 1800 pi. See, how do you solve? See, V is equal to sigma r by epsilon naught. So if you try to substitute the values, direct formula 1800 pi volts, where epsilon naught value 4 pi into 9 into 10 power 9, 1800 pi. Okay, surface area, you need to take surface area. Come on, people watching online, do like, share the session. So the next question, minus check. You will have both in options. What will you mark? Check. See, these are questions from electrostatics. Try to solve. Come on, people watching online, share your answers. It is square of side root 2, and these charges are present at its four corners. Find the potential at center. Okay, correct. Soumya, correct. Next, second question. How about second question? Okay, minus 18. First one. So, ప్లస్ 260 మైనస్ 260 రెండు ఉంటాయి ఆప్షన్స్లో. కమాన్, మైనస్ 260. సో ఫైనల్లీ మైనస్ 260 దగ్గర లాక్ చేసిన ఆన్సర్ ప్లస్ 260. సో కమాన్ పీపుల్ వాచింగ్ ఆన్లైన్, సెకండ్ క్వశ్చన్ ఆన్సర్. ఎస్, ఫస్ట్ క్వశ్చన్ 260 volts correct, Mr. Gautam. Miss Soumya correct. So do share the session, like the session so that many get benefited. Okay, it motivates us to do many such sessions as we are doing it for free. Correct, Gayatri? See, second answer minus 18, not plus 18. Check. See here, the distance is, how much will be the distance of point? Distance of point. Okay, you can do the as that value. Okay, so distance is root 13. The V is equal to Ex bar, we will get as 260 volts. See, how about this? Here simply potential is equal to K Q1 by R, Q2 by R, Q3 by R, Q4 by R. So as R is constant, as R is same, so you will get as minus 18 volts. There is nothing much logic involved, direct straight formula questions. 19 wrong answer, minus 18. So people watching online, do share session, like session so that many get benefited. See, I am waiting for you to answer. See, I can write the answer right from moment I write the question. So there is no point in just giving question and answer, right? I need to give time to solve as well. So it takes bit time. Okay. See, my honest suggestion is that whatever might be the question, how simple might be the question, try to write the given data and solve. See, it's a kind of practice. Like, see, in exam you cannot have that, you cannot take that chance. There is a very good chance that you may go wrong. So even it is 3 into 3, you need to write 3 into 3 is equal to 9 and then go ahead. Okay. See, there is a very good chance that 3 into 3 you may write 6. See, even second class student know that. but make sure that you follow a standard procedure. The binding energy per nucleon of carbon 12 is 7.68 million electron volts, and for carbon 13 is 7.47 million electron volts. What is the binding energy required to remove a neutron from carbon 13? It is not 3.5, Miss Soumya, first one. Mr. Naveen, there won't be any kind of postpone. So don't. Huh? People are still hoping for postponement. So do like this session, share the session so that many get benefited. So how about this direct question? Second one, direct question. Not. No. Come on, people watching online. Okay, 3:5. Okay, 3:5, correct, not 3.5. Okay, 4.95 million electron was correct, Soumya. Come on, people watching online, do share this. See, it is 4.95. See, first let us do this. Here R1 by R2 is equal to A1 by A2 whole power 1 by 3. Nothing but 27 by 125 whole power 1 by 3, you get as 3 by 5. How about this second one? See, first you try to calculate the total binding energy for carbon 12. See, you don't need to study modern physics to solve that question. See, per nucleon it is 7.68. Per nucleon it is 7.47. There are 12 as such here. There are 13 as such here. So, if you try to remove 1 from 13, it will become 12, right? So, find total binding energy for carbon 12. Find total binding energy for carbon 13. You subtract them. You will get the energy required to remove 1 nucleon. See, you don't need modern physics for this. Basic mathematics, aptitude. So you will be getting around 4.95, something as such, right? .95 million electron volts. See, even if you don't know the concept, you can make out from the question. So we will do last couple of questions and close this session, okay? ఏముంది చేసే అందులో ఏముంది చేసుకో 000 అని So let's try to close the session with a easy question, okay? So we are focusing more on units as well. So try to solve this. Come on, people watching online, do like, share this session. So try to match that following. No, single option. So what is joule? Joule is on AF. see here it is okay, ABCD. See, for our convenience, let me so what is A? G, right? Okay. What is B? J. What is C? E. Where is E? Okay. What is D? F, right? Basic things: joule, coulomb volt, okay, watt, J, ampere square ohm, volt, E, Henry ampere per second. So you need to be aware of all these basic fundamental units. D, F, parallel. Okay. So last question, bit tricky question. Ratio of capacitances of capacitor. See, my question is, two capacitors were charged to potentials 80 and 30 volts. Okay, were charged. Were charged to potentials 80 and 30 volts. Then they are connected in parallel. The potential difference across the conductor is, capacitor is 60 volts. Ratio of capacitances of capacitors. So come on. Initially, then they are connected in parallel. So it results in potential difference of 60 volts in the ratio of capacitances of capacitor. Hmm? 3:2. Correct. So how do you solve? Yes, Soumya, correct. Come on, people watching online, like, share, subscribe the Roots Academy so that it really encourages us and motivates us to do many such videos. So see, what is the concept used here? Law of conservation of charge. Okay. Firstly, they were charged to 80 and 30 volts, right? So what will be the net charge initially? Q is equal to 80 C1 30 C2, right? Okay. That is Q initially. What will be Q when connected in parallel? What is 60 into C1 plus C2. So can't you find the ratio from these two equations? Two equations, two unknowns. Solve. So you will get something around, so you will get 3:2. Okay. So by this we are trying to end our session, revision session on physics. We covered first year formulas, second year formulas, first year problems and second year problems as well. So those who are new today, just go back to the revision playlist, quick revision playlist. You can find all those videos. We try to cover important concepts, formulas, problems from previous year questions that are being repeated. So this helps you to score minimum marks in any competitive exam that you write from physics. Okay.
So thank you for being so patient, trying to solve. So I wish you a very good luck for your future exams. So thank you.